Um, this has become our go-to activity for a lot of events that ASCE gets called on to do. And I have done this particular activity with preschoolers. The girls that you see there, those are Girl Scouts. They're about middle school age. And we've also done this with adults at different outreach events. And it's a good activity. You get a lot of fun out of it. The little kids enjoy it. It's great for encouraging families to work together. And it is surprising how much tension comes into this activity, because what they do is they come up and they test it in front of a fan. And they start off with the fan, and in a little bit I'm going to be showing you this in person. But when they do come up to test it, they start off at about 3 or 4 feet away from the fan, and then they keep moving it closer. And you can see that one of our Girl Scouts there has her fingers in her mouth because she's really you know caught up in is my design going to work. I've seen a lot of happy dances. It's really kind of amazing. um, I'm going to just double check what my next slide here is. Yes. And for Windy City Tower, it's very simple. The constraints are basically 3 sheets of paper, and we're just usually using the 11 by 17 ledger paper. We use 1 washer, no more than 2 yards of tape, and the washer can't be taped onto the structure. So I'm going to start my webcam now, and I'm going to start sharing. And Brooks, how do we switch over so that people can see what I'm doing here?
Do you mean, yeah, that's fine right there. That's a good view.
Okay, are they seeing my webcam? There we go. I wanted for it to be a little bit larger.
There we go.
And, I wanted to show you this one version of Windy City Tower because I just thought this was so slick. The first time I did Windy City Tower, it failed. I was one of the people who thought I'll build a design where the point of the building faces into the wind, which isn't necessarily a bad idea, but in my case it really didn't work. And somebody else at the workshop I was at took the washer, and instead of viewing the washer as something that had to be put onto it and was extra from the tower, the washer became part of the tower, became part of how they actually connected it all together. So I've rolled my stuff into 3 tubes, and now I'm putting the small points here, and now it's sort of settling on down. But you can see that, hey, I have a tower, and if I check my height, I'm actually supporting it at exactly 14 inches above the surface. And it this design, I have to admit, really amazed me. I thought it was pretty cool the first time that I saw it. I'm also going to make a cultural connection that just occurred to me here. This is actually the way that Native Americans built teepees. They would start with their 3 poles. They'd have them flat on the ground. They would lash them together at the top, raise them, position them into a tripod, and then start adding additional supports and just whipping their rope around at the top to continue to make it really secure. So I thought that was really kind of fun today to realize that it is actually very ancient engineering here. And I'm going to go ahead and turn on my fan, and you can see that this holds up pretty well. I was like, I should have had this, be dramatic so that you could really, really see that I've got the fan going pretty strongly here, and I can keep moving this up. Of course, it's changing even as I do this. So if I was going to keep engineering it, it's not 14 inches anymore. So if I'm going to engineer this a little bit more, what do you guys think I could do to improve this? trying to see if we've got any comments coming in from people about, what do you think I could do to make this better? More tape. Yeah. One of the things that could be done is to, put a ring of tape up here so that it can't keep going further down. I could also put a little bit more engineering into the bottom to make those a little flatter. One of the things that we've told people when they do this activity is that the washer can't be taped on itself. And one of the challenges that you have with an activity like this is that it's amazing how many ways that people will come along and reinterpret what you have said. So you really kind of need to be open to unexpected results. I got a little chastised at one point because we had said that the washer couldn't be taped on, and they put the washer inside like a little paper envelope that they made. So there was no tape on the washer, but there was tape on the envelope, and that's how they kept the washer in place. I have seen people do designs where they do a building with points and they face it into the wind. I've seen people who use the tape as a guy wire, so they run the tape down to the base. I've seen the flying buttress. And of course, this is the TP design. I've also had people who have built their structure on a piece of paper, and then I didn't tell them that they couldn't take an extra washer and put the washer on the piece of paper, so that gave it a little bit more stability. So sometimes when people come up with things, it's like you don't really know what to expect, but it's a lot of fun because then you can look at it and say, oh, well, what do you think? And if you're not sure if they met the challenge, ask the entire group what they think. Can people see the slides still that are down? I see slides over in the bottom right. And if you can see those slides, I just want to point out that there's 3 different designs there that are very, very distinctive. And that's what's so fun about these engineering design challenges, is that they come up with things that are very different. I'm going back one slide if I may. Oh, too far. Those 3 designs there, these 3 designs that you're looking at all worked equally well, including the one in the middle with all those flat surfaces that you think would like fall over. The female engineer who designed it, when I said, wow, I'm just amazed that design did so well, she said, well, I am a structural engineer. This is what I do every day. So are there any questions about Windy City Tower? Oh, somebody asked, what's the size of the washer being used? It's in the instructions. Unfortunately, I can't remember off the top of my head. The one I'm holding right now looks to me like it's about 1.5 inches for the outer diameter, and maybe around 1 inch for the inner one. It really doesn't matter too much as long as everybody's washer is consistent. And I'm trying to see if there's Mary suggested putting some string around the outside, and that is a possibility, but in this case we don't even provide people with a string. This is something where you give people much more constraint in terms of what they're able to use, but certainly, if you were to open it up and allow them the potential to use string, they could use string, they could use tape. Judy's saying it's a 2-inch washer. And I believe you, Judy. I've been doing this for so long, I don't remember anymore because I just went to the hardware store and I bought these like a year or 2 ago. So because I've been using this activity a lot as we were developing things for Dream Big.
And Janine, this is Brooks. I just want to jump in and say that we did this for our Project Build kickoff meeting, and it was the most fun. we all had a blast. So it's not just a children's activity by any means. It's definitely applicable and fun for adults too.
And I think actually, ironically, somewhere along the line, somebody assigned a grade level to it that might be like sixth grade and up or something. And I'm like, what? When did that happen? Because, like I said, I have done this with preschoolers, and they may be getting a lot of help from their parents, but the parents aren't completely taking over the activity. And it just goes to show that a lot of times grade levels, if you look at it and you can see, I can see how this can be adapted to a younger audience. I'm all for going and doing it and finding out what happens. And how many designs can they typically do in a 45-minute session? In a 45-minute session, you're going to be surprised if they're really taking some time and putting some effort into the design. They may really only work with one prototype. When I do these for the outreach events, it takes less time because parents are helping, adults are helping. But a lot of times, I think like the older the kids are, the longer it takes them to do it because they do tend to be using a little bit of thought before they start building. But I would be surprised if there were more than 2 iterations. And is it more individual construction or is teamwork possible? Well, I think we still have that slide up that shows the engineers who did this, and a couple of the people did it on their own, and the other people got together, and we had like 8 people on the team. So it can be done either way. The nice thing is the materials are pretty simple, so this is one where if you really want to make sure everybody's got their hands on it, it is possible to do this in very small groups, either individually or teams of 2. Okay, I don't see that anybody else is